Hi everyone, welcome back to Chem Help ASAP. In today's video, we are going to be doing not only a limiting reactant problem, but we're also going to be calculating a percent yield for that problem. 5.04 grams of solid lead 2 nitrate react with 5.68 grams of solid potassium iodide. If 1.98 grams of solid potassium nitrate are formed, what is the percent yield of the reaction? The first thing we need to do is write our chemical equation. All right, so we have lead 2 nitrate. This is going to be this, lead 2 nitrate, that is solid, reacts with potassium iodide, also a solid, and that gives me potassium nitrate, that's also a solid. And it looks like I need to predict our other product here. This is a simple double replacement, so therefore I have lead 2 iodide as my other product there. Okay, I have a chemical equation. Now let's balance it. Let's see, I need a 2 here and a 2 here, and then we are balanced. Now I'm going to calculate my molar masses that I think I might need. Here are my molar masses. Our next task is to determine our limiting reagent. So the first thing I'm going to do is I'm going to convert both of my grams of reactants into moles of reactants, because we are doing stoichiometry. And in stoichiometry, when in doubt, always go to moles. There are my moles of my lead 2 nitrate and my potassium iodide. I am going to test one of these. I am going to test my lead 2 nitrate. So if I'm going to use all of my moles of my lead 2 nitrate, I need to determine how many moles of potassium iodide I'm going to need. I need to use my mole ratio right here. Oh, excuse the error. This should be a 2, not a 1. I am going to need at least 0.0304 moles of potassium iodide. That's how much I need. How much do I actually have? I actually have 0.034 moles of potassium iodide, so I have extra. So therefore, my potassium iodide is in excess. My limiting reagent is my lead 2 nitrate. I'm going to box it, put a big LR up here because this is the number I want to use to do any other calculations. Let's predict what our theoretical yield is using our stoichiometry. So you can see I have started with my moles of my limiting reagent, my lead 2 nitrate. I am going to use my mole ratio to switch from lead 2 nitrate to potassium nitrate. And once again, that should be a 2. Apparently I can't type in 2s anymore. That should be a 2. And finally, I am going to convert from my moles of potassium nitrate to my grams of potassium nitrate using the molar mass. Here are the grams of potassium nitrate that I should form if I run this reaction. Now the problem told us that we did not actually form that 3.0775 grams of potassium nitrate. We only formed 1.98 grams. So using my mathematical formula for percent yield, which I give right here, I'm going to plug in my theoretical yield down here that I got from my stoichiometry. That's how much I should get. My actual yield was given in my problem. That's how much I actually got when I went into the lab and ran this, times 100%. My percent yield is 64.336. With the correct number of sig figs, my percent yield for this reaction is 64.3%. So there we have it. That is our percent yield for this reaction. If you need help understanding how I ended up with 3 sig figs for this calculation, I'm actually going to break that out into another video where we will go over that. Thanks so much for watching.